Ah, check, check.
one of you to the second edition of OIS 2.0, Organics in Space, a national conference that brings together visionary minds exploring the frontiers of chemistry, biology, and space science.
We are honored to host you all here at GITAM deemed to be university, where science meets curiosity and curiosity meets the cosmos.
To formally open the session, may I invite Dr. Shubhadeep Chakrabarti, convener of OIS 2.0, to deliver the welcome address. Dr. Chakrabarti has been a driving force behind the conference. Sir, the stage is yours.
Good morning, everyone. On behalf of the organizing committee and entire GITAM administration, I extend my heartfelt welcome to our honorable chief guest, Dr. Shiv Kumar, distinguished guest, Shri S. Kiran Kumar, guest of honor, Dr. Somnath, and Dr. Tarun. So, in the ASI Symposium 004 on the genesis and evolution of organics in space at GITAM Bangalore. The symposium is a part of the larger Organics in Space initiative, a national effort to explore how organic molecules form and evolve in the space. And that tells us about the fundamental questions about the origin of life. It brings together the experts from diverse domain that starts from astrochemistry, astrobiology, planetary science, laboratory astrophysics, and space technology, a truly multidisciplinary gathering. On the next few days, let's share the ideas, spark collaborations, and shape the future of space research in India. I sincerely thank our guests, our speakers, our dignitaries, and ASI, GITAM leadership, and all participants for being the part of this journey. Welcome once again. Let's have a stimulating discussion, a full symposium. Thank you so much.
Thank you, sir. Now we would like to invite Professor KNS, Professor Philip, Shri A.S. Kiran Kumar, Dr. S. Somnath, and Professor Tarun to the dais. Ladies and gentlemen, please join us in welcoming the dignitaries with a warm round of applause as they come forward. Now I invite Professor KNS to felicitate Shri A.S. Kiran Kumar.
I invite Professor Philip to felicitate Dr. S. Somnath.
I now once again invite Professor KNS to felicitate Professor Tarun Swaradip.
Next, we invite Dr. Umesh Kadane, co-convener of OIS 2.0, to give us a brief overview of the conference and the exciting journey that lies ahead. Dr. Kadane, the stage is yours.
Good morning, all the dignitaries on dais, off the dais. Very welcome to this second symposium, the ASI 4th Symposium on Origin of Life in Space via the processing of organics. This is something which is a very interesting topic, which is scientifically has been very exciting and challenging, and now it has become a technological challenge as the space missions are bound to get more and more samples from space. We are going to explore the space. So keeping that in mind, 2 years back, we started this initiative. This initiative is called Organics in Space in short, and basically the origin and genesis of organic matter in space, ultimately leading to understanding of how life originated in space. So for this, as you can imagine, a variety of skills were required, and we had to bring a lot of people on board, and with the impetus given by our chair, that time ISRO chairman, Dr. S. Somnath, we could actually collect a large gathering of scientists, and this is the third meeting where we are meeting this. And in the last meeting, in January 2024, we chalked out a 3-phase plan for this initiative. The first is to basically connect, to orient, consolidate and enhance the research background we have already, the scientific know-how in the country, and do a capacity building. The second is to establish very specific task-oriented, goal-oriented facilities and research laboratories on ground and if possible in space. And the third one is to actually make a proposal to our space agency jointly to explore the interplanetary space, collect samples, do in situ analysis, and bring the samples back to Earth to do more analysis. So with these ideas in mind, we formed a national work group, which is now swollen to 85 established faculty and scientists from across the country. And we are guided by a national advisory board, which is led by 7 eminent scientists from the country. We are also trying to reach out to international labs to learn from their experience and their expertise. And I hope that this second meeting of Organics in Space will definitely add great value to this. To this end, we have now invited research proposals, and I'm glad to report that from 28 institutes across the country, we have received 20 research proposals, including 3 proposals for national facilities, and 3 very prominent national institutes have agreed to host them. So we are now preparing a proposal worth 90 crore, which will be presented to various funding agencies as a consortium funding. So while we all continue to strive, struggle, and grow in our own, sorry? Okay, sorry. Yeah. So as we continue to grow our research individually, we want to grow as a consortium. So programs like this, we wish to form more bonds. And very important session today, the second session today, will be a panel discussion where we want to receive criticism, corrections from all of you, where we should improve our ways in coming years. I wish the very best to this event today, and thank you very much once again for joining.
Thank you, sir. Now let us begin this day of learning and inspiration by invoking light and knowledge. We invite our dignitaries to the front for lighting of the ceremonial lamp, symbolizing the radiance of science and truth.
We are very delighted to have Dr. Kalyan Raman, CEO of ANRF, our chief guest online with us. Welcome, sir. To share his words of encouragement, we now invite Professor KNS Acharya, Pro Vice Chancellor of GITAM, for the opening remarks. Sir, we are eager to hear from you.
Good morning to everyone. I know that you are not eager to hear me, but hear them. But let me keep my opening remarks very, very brief. I would say this is an extremely momentous day for GITAM Bengaluru campus. I can't imagine so many luminaries being on the campus on the same day. The discussion about organizing this Organics in Space Symposium started about a year back. That's when we had last year we had organized a space day, National Space Day on the campus, and that is the day when we said we want to be part of this journey. I am really thankful to the OIS organizers for having chosen GITAM to be partnering with the entire symposium. Now, what is organics in space? What kind of research has to happen, etc. Umesh and others, they have already spoken about it. I'm not going to spend time on it. I was just discussing with Dr. Somanath how many times in a day or a month or a week both Kiran sir and Somanath sir are together in one place. They said very rarely. I said this is an opportunity for GITAM to have brought them together on the same stage on the same day at the same moment. Right? We will take pride in that. I less spoken about ISRO. That is a jewel in the crown of the country. The kind of activities, research, as well as the pride that ISRO has brought to country. A big round of applause for the entire community of ISRO. Without the luminaries of that nature, we would not have been the country that we are. The GITAM University, in our own way, we are trying to contribute for the growth of sciences as a community. We have fantastic faculty members. They both kindly took out time to go around a couple of our laboratories. I hope they get a sense that we are making some baby steps in the cutting-edge research that we want to do along with industry as well as research organizations. Once again, I will also thank Dr. Shivakumar, who has also joined us as chief guest from ANRF on the call. Thank you so much, sir, taking out time to be with us this day. Professor Tarun from RRI is also taking out time to be with us, and many other dignitaries I see who have come all the way from both India and abroad. Once again, from GITAM management, I thank all of you to have grace for this occasion. Thank you so much.
Thank you, Professor Acharya. We now welcome Professor Reggie Philip, Principal, GITAM School of Science, to address the gathering. We look forward to your words of wisdom.
Respected Dr. Shivakumar, Shri A.S. Kiran Kumar, Dr. Somnath, Professor Tarun Sauradeep, faculty colleagues, guests, and students. A very good morning to all of you. It is an honor and privilege to welcome you all to GITAM Bengaluru for the ASI Symposium on the Genesis and Evolution of Organics in Space. I am extending this welcome once again, even though the conference organizer has already welcomed all of you here. This is a gathering of some of the finest minds in planetary science, astrochemistry, and space exploration. This symposium is not just another academic event. It represents the coming together of a national vision, the Organics in Space initiative, which aims to unlock one of the most profound mysteries of our universe, of our existence. How did life begin, and what role did organic matter in space play in it? As an academic institution, we at GITAM feel deeply committed to such visionary programs. At GITAM Bengaluru, we are in the process of creating a space research ecosystem where our faculty members are working in the frontier areas of space science. At a time when India's space capabilities are rapidly growing, this initiative offers a clear opportunity to define a national roadmap, one that includes laboratory research, instrumentation, space mission design, and global collaboration. We are very proud to support this movement. I extend my warm congratulations to the organizers, the National Advisory Board, and all the scientists who have been instrumental in shaping this initiative. Let the symposium ignite new ideas, foster new collaborations, and most importantly, nurture a vibrant research ecosystem that takes Indian science to greater heights. I wish the symposium great success, and thank you all.
We are privileged to have with us today some of the most esteemed minds in Indian space sciences. Their presence is both an honor and an inspiration. First, we invite our chief guest, Dr. Shiv Kumar Kalyan Raman, CEO of ANRF, a pioneer in space and research innovation. Sir, it's an honor to have you with us. We look forward to your address.
Good morning. Confirm if you can hear me.
Yes, sir, we can hear you.
Okay, perfect. Okay, so first I should clarify that I'm not a pioneer in space for sure. My area is but I'm here speaking on behalf of Science and National Research Foundation and And also sometimes also a non-governmental partner who comes along with us. I'll give you some examples shortly. But one of the very important things that the Honorable Prime Minister has asked us to do is at the very early stage itself have more partnerships with non-governmental stakeholders, whether they are like foundations, CSR, and so on, or even partners from industry and startups, MSMEs, and so on. So we are doing many such partnerships going forward, and there are different ways in which these participation can occur. I'll give you a few examples as well. So in terms of our recent programs, we have done, I'll give you 3 examples of programs. One is called a PAIR program, which is a hub and spoke research capacity development program, where we've 100 crore grants to combinations of hub and spokes, where we have each hub has about 7 spokes, we've had 7 hubs. IIST is one of the hubs, for example, from Bangalore. Bangalore University is one of the spokes, and there are other spokes that IIST has all across the country. So similarly, there are 6 other hubs and many more spokes. There are about 45 spokes. And we also funded some emerging hub and spoke combinations at a lower level, where we can encourage them so that they continue the collaboration and support in the future. So this is a very important program to uplift a more broader set of institutions in specific areas where this research capacity, both infrastructure as well as collaborations can be encouraged. The Prime Minister Early Career Grant Program supports a large number of our sort of young researchers in the early stages of their career. Again, that's a program we are very happy, and we've increased the number of grants this year as well. And these are individual-centric grants of about 60 lakhs each with overheads. And we've also liberalized a number of things such as foreign travel and other things are permitted as part of these grants. The other is mission mode programs, which are more driven by economic considerations. And there again, you have a hub and spoke type setup with a lead PI and other PIs, but we are governing that very closely to make sure that there is industry partners, there is pathways to impact. So this is the first of our missions that we're launching. So if you follow our social media, and I would strongly urge any researchers interested in funding from us to kindly follow our social media, whether it's LinkedIn or Twitter and so on, where we are posting such programs. In fact, in the last week, we announced a couple of programs, a Prime Minister Professorship Program for uplifting state universities, as well as we have launched a new program at the intersection of social sciences, humanities, and science and technology. These are the ones, and please expect more such programs to be launched shortly. I keep joking, since you're in Bangalore, if I can allow to make a joke, which is just like Rameshwaram Cafe dishes out dosas, will be cheaper programs. Okay, so there'll be a lot of programs, no shortage of that. So, so the hub and spoke is an important program. As you can see here, we've had several hubs, and around that spokes across the country, and both the north and south, east and west, we have representation of these spokes, and we are genuinely interested in helping them develop. And there are many more spokes not select this time, but we have increased the numbers. So in terms of the vertical missions, we look at vertical missions in 2 ways. One is more of driving value chain growth. So we have electric mobility that we launched. There are some others which are coming out shortly, and these will be announced. And we'll do something called a pre-CFP, followed by stakeholder consultations, and then do final CFP. So some of the candidates that are there are mentioned here. There's no guarantee that we launch each one of these programs, but expect us to make some announcements in some of these areas shortly, coming up soon, right? So that is in terms of the value chain, similar to how we've done electric mobility. And then we are also looking at India Challenges type of program. The Honorable Prime Minister has asked us to look at taking on India's hard challenges, and then looking at developing technology, interdisciplinary technology, and where we can also have unique unit economics, and then take it to the world as well. So one area we are working on is around reimagining agriculture. So I know ISRO is working closely with the various agricultural entities. So we are looking at building some open data platforms across various agricultural entities. But we're also looking at various other domains, whether it's energy, transportation, groundwater, or water in general, urban flooding, pollution, infrastructure, and so on. These are just some samples. Again, there's no guarantee that we'll launch a particular program in any area, but typically we are looking at cross-ministerial, cross-disciplinary, and in some areas where we bring in partners to co-fund alongside us, right? So wherever these factors tend to play out and wherever there is greater momentum, we will launch there. For example, we are soon going to be doing something around AI meeting science and engineering, where science and engineering can be directly modeled in AI, or new data sets and new models for science can be developed, which can then accelerate various application areas in science. So we are also working with several partners. So we've started signing up partnerships. So we've done one with the Gates Foundation, the other with Wadhwani Foundation. In general, the pattern is that partners invest in ANRF programs. As you see, ANRF programs are a dynamic one. They are launching new programs over time. So, so that's the general pattern. So we are inviting various kinds of partners to join us and expanding our programs as well. Okay. Further, I think importantly for us, social media is a very important area where it's not just for publicity or marketing, but truly to really celebrate our researchers, celebrate the research that's done, and also make it a first-class medium for research dissemination. I strongly believe in this, and therefore we are doing many social media initiatives, including creating channels for each of our major programs. And we are actually picking up when people tag us in this, and then we are to sort of pick those streams up and highlight their work as part of our ANRF social media pages. Similarly, we are using social media also as a means for doing ESO science and helping sort out many of the bottlenecks and so on. And recently, we've also helped sort out many challenges in submission and things like that. In addition, we are also putting out a lot of tools for democratizing research. So, for example, if you have a complex paper that you can't understand, we are we're partnering with TIFR Hyderabad and a bunch of independent researchers to put together a tool called or a platform we're building called Saral, which will be democratizing research using AI and social media. So you can take a paper or a preprint and then convert that into a video, convert that into any language of your choice, and make it simplified. Right? It's a combination of converting it into your context, your favored way of understanding, and also in an engaging manner going forward, right? And also in any languages. So we currently support 11 languages. We are partnering with a Bengaluru company also, Sarvam.ai, which is working with us in the India AI mission. So we'll be further expanding this into more of an Anusandhan community platform, an open science thing, and also to allow sort of mentors, mentees. We'll be gathering problem statements around the world as well as in interesting ways. And overall, this will be part of a larger master platform for India research information. Okay, so first, since I just wanted to clarify, and this is an overview of ANRF as a whole, number one, and so this topic that you have in your conference, which is Genesis and Evolution of Organics in Space, it's a very fascinating one. I was really pleased that Dr. Somnath caught me at IIT Madras and said, you must work with us and help us as we grow. I look forward to further conversations and outcomes from your conference today, and talking to Dr. Somnath and seeing how, along with ISRO, along with the space community and the other communities, looking at this, the biotech community, mechanics community, the agriculture community, and so on, right? So wherever there is interdisciplinary areas, ANRF is supposed to get involved, but we need to structure our support for this. Of course, there are these broad-based programs you can leverage as well. So let me pause here if there are any questions.
Thank you, thank you, Dr. Kalyan Raman. For any queries, the audience.
If you have any questions and want to take one or two questions from the audience.
For any queries, the audience is requested to post it into the chat. Now we invite Shri A.S. Kiran Kumar, former Chairman ISRO, to address the audience.
Good morning to all of you. Good morning. Thank you. Kalyan Ramanji, Somnath, Tarun Saurodeep, and then Reggie Philip, and the Vice Chancellor of GITAM University, and all of you who have gathered here for, in a way, a very unique event where you are looking at organics in space. See, if you look at life itself, actually, life grows constantly. I was reminded of a challenge which was thrown by one of the designers in one of his TED Talks. He was telling, can you design a car or a robot which can reproduce itself by picking up material from surrounding it? If you just look at this problem, it looks fantastic problem. But then if you look at all forms of life, from plants to egg-based to mammal-based, all life forms are doing on this planet this activity day in and day out. They have found a way of picking up the 5 Panchabhutas, what we call, and using that, they are creating replicas of themselves and going ahead. And if you look at human development, human activities on this planet Earth, all the time, the effort is to expand the capabilities that you have, go beyond your own current features that you are endowed with, build new capability to explore the universe. And today, there's a huge amount of work going on in all disciplines to reproduce life from non-life material. So far, of course, the success has only been starting with life, modifying, and moving ahead. But then, the effort of creating life from non-life is the real challenge which is going on. And in this context, what you are going to discuss and listen to from Organics in Space, if you see, it is how non-life matter became life matter, and what were the various activities. Lot of research which goes on shows how shock can change the behavior of certain molecules, certain materials, and how magnetic fields can change, and how radiation can change. In all this, there is a constant understanding which is in progress to look at creation of life from non-life. And in this context, today when India is moving ahead with its space technology capabilities of looking to put humans in space in a couple of years, and then building its own space station by 2035, and landing on moon by 2040, and then life beyond planet Earth, there's a huge amount of activity that is going to go on. But then, if all these opportunities also have to be utilized, and then we need to make a difference to the way we understand the universe, then events like what is being planned here, trying to showcase how people in India, various academic, industry, and other entities can come together and look at how we can address different aspects of life, and then try and visualize how can the human desire to create life from non-life entities can happen. So let me wish this program a great success, because already what we have seen in a couple of years, the organizers have brought together a large number of participants who are working in different disciplines, different fields, and you will also realize that this activity is not limited to one discipline of science. It is life, that means every aspect of life comes into picture. There is no field which is not covered, no discipline which is not covered. That means everybody can become a participant in this process. And what the organizers have already done is a great effort of bringing in a huge amount of people working across the country, showcasing to them that if we work together, if we start addressing problems, then probably we can make things happen very differently from what rest of the world has done. And here again, one of the key things that we need to appreciate is the life form that we have, humans. There is a way of exploring the universe from understanding what is there within you and your asli intelligence, how it works, and how it actually takes care of you during your exploration of the universe. And in this context, I wish the organizers a great success and wish all of you a great exploratory journey of not only exploring the world, but also making sure that you contribute to understanding the universe. Thank you very much.
Thank you, Dr. A.S. Kumar. Audience is open to ask any questions if you want to. We now request Dr. S. Somnath, former chairman ISRO, to share his insights.
Good morning, all of you. Shri Kiran Kumar, Dr. Kalyan Raman, who is online, Professor Ken Acharya, Dr. Tarun Sauradeep, Professor Reggie, the principal, the conveners of this Organics in Space conference, Professor Chakravarti and Professor Umesh Kadane. Greetings to each one of you on the occasion of this inaugural session of this Organics in Space. And thank you for inviting me, and really happy to see the idea growing in strength, bringing in a lot of delegates across the country to have the Organics in Space continue in its journey. And I was wondering why you are named it as Organics in Space, not Life in Space. And I believe that you are talking about, I believe, the same stuff, right? The life in space. I think, you know, the story of life in space is something very interesting. I think wherever I go, I get the question of, is there anywhere else life like aliens? And this is a standard question. And I believe this is again a conference on aliens. I think you can take it like that. So it will be a little more exciting for you, not just organics in space. You can look at it as a story of aliens, because I happened to see one of the movie that was prepared by, or also of a video documentary prepared by alternate forms of life, other than that is visible on Earth. I think we are all familiar with the life on Earth, which is basically based on carbon and sustained by the presence of other systems like the presence of carbon dioxide, oxygen, water, the energy sources from the sun. I think all of them make sure that life sustains and thrives on Earth. But the question of whether any other forms of life that can exist elsewhere. And today you know that the knowledge about all of this came because there is space technology. I'm very proud of that, because everywhere I must say that because of space technology, that you are able to probe the universe deeper, understand the possibilities of existence of life sustaining places elsewhere in the universe other than Earth. Today we talk about exosolar planets because they have been detected large numbers now because of the platforms that you have put in space, like the observatories in space, like the Hubble, the Chandra, the Astrosat, and things like that. And we are able to detect large number of exosolar planets, and many of them are at the sweet spot where the life could be sustained. Possibly the sweet spot is not the sweet spot that actually the life will be sustained. We know about only Earth, where we are at the right place, where the water remains as water, liquid water. The temperature is right. The radiation is appropriate for us to survive. The ultraviolet radiations are blocked so that life is not threatened. And many, many things happen here. Just the right place for life to originate and then sustain. But in other places where the life can originate, possibly is not in this similar situation. And I'm not really worried about that part whenever I understand this domain in a way that life can actually be originated or created in places which are much more harsher than this. Possibly the life originated in places much more hotter, sometimes much more radiation, much more ultraviolet presence, and many other things that could actually trigger creation of life. But then life also evolved over many years of time, millions of years, billions of years really, to the state which we are here. And I was again fascinated by a question, who is the most evolved life on Earth? I think this was a question when somebody asked whether human being is the most evolved life on earth or is bacteria the most evolved life on earth. Then I sometimes, the right question is that I think all of us are the most evolved life, because the most evolved life only survives now. And the one which has not evolved has all got extinct. I think all that life that is getting extinct are the one which is not competent enough to survive with the current environment. And only one who actually have an ability to evolve and change and modify themselves to accept the current present environment only survives. I think that includes human beings as well as microbial organisms. I think all of them are the most evolved creatures on earth. I think these are good thoughts for all of us to talk about life on earth or everywhere in the universe. But I talked about the life that are possible elsewhere. I think this is very exciting for people to look at alternate chemistries and methods by which life can actually be created. You call about organics. Organics, again, talk about this chemistry based on carbon and other elements. But there could be other chemistries where the solvents or electrochemistry is driven by other solvents like methane, ammonia and things like that, not water, which is the basic, the conductor or the solvent of life on earth, whereas other forms of life is very much possible. But then this becomes exciting for all of us, and then want to explore this, possibly going there and picking samples, analyzing whether life actually originated in space. And there are two schools of thought for creation of life on earth, that it actually originated using a biochemical reaction that actually happened on earth because elements are present here, and because of a certain primordial soup that existed at some point in time, reacted upon by some activity, could be lightning, could be impact of many things on earth. Life originated as a complex molecule which found a way to replicate itself, then created the so-called life into it by the Almighty, and then the Almighty suddenly comes. I think all of us are interested in that also. When we talk about life, we talk about somebody who has actually put life into it, those replicating molecules. I had opportunity to read a recent book by Robert and Cross, who talks about the edge of knowledge. I think possibly some of you would have read that book. The book is a very interesting book which brings about various elements of the understanding of space. It talks about the time, talks about space, it talks about matter, then talks about life, and then it talks about conscience. I think this is a very interesting continuity of things: time, space, matter, life, and conscience. I think people who are interested in these type of things should also discuss topics of this nature. The life, of course, will lead to the topic of discussion on conscience, whether there is a real conscience, whether there is a universal conscience, it's get into the life forms, whether this conscience is the real conscience or we are talking about it something which is not existing at all. I think these are all interesting stuff. I think this keeps young people who are coming here getting excited about it. And I told you in the beginning that alien is something all of us are excited. But then why at all we should do this domain? I think what is the interesting aspect of understanding how life got created, how it sustains here on earth, whether it originated from earth or from somewhere else through, and then get distributed across the universe. Life get distributed through some magic means because it's originated somewhere else, and it has a way by which it spores of the life that actually spreads across the universe, and it gets collected in pockets of places where it has a possibility to survive, it survives and expand. So that way there could be many places where an identical nature of the life that exists on earth could be present, or could be a different mechanism by which the life at different places could be of different nature than what we actually see here. I think these are possibilities for science fiction writers and also equally possibilities for scientists. I think both of us need to work on this and understand it. The whole purpose and goal of such conference is basically to bring that type of mindset where we need people from different domains, people from space who looks at exploration and understanding of other celestial bodies, possibly look at search for more exosolar planets, look at with spectroscopy and other technologies to seek possibility of life creating environments in these places, collecting samples from this and do analysis in ground and to understand whether complex molecules could be created in space and then whether it could be the basis of the creation of life here. Possibly do experiments on the earth to validate those hypotheses on a continuous manner. Maybe one day one of you will create a life on earth which is different chemistry than what you know as existing today, possibly that also. The question of life is little more complex than a complex organic molecule. I think that all of us know that. Its organic molecule is one part of the life only. But then it has to have a methods to replicate itself. It should know how to replicate itself. And it should also write the history of its replication into it through the process of creating genomics. I think how do you write history? Who are my father, my father's father and mother? I think all stories and by traces of me are always written into the story of genomics. And how gene structure can actually be created in life, which is very essence of the current form of life, and whether any other methods are possible other than genes to create the history of life into it itself, so that the reproduction actually produce the same features, not any totally different features are not allowed. I think this is again another thing, whether magnetic processes are possible, whether any other chemistries are possible to replicate other than the protein way of writing the story in a thread of DNA. Whether any other methods are possible. I think these are next levels of understanding that is needed. So we are still at the beginning phase of understanding life. I think this is the interesting part. Though we have been living here for possibly a few lakh of years, human beings I talk about, not the other forms of life, but our ability to understand life is still very primitive. I think that is a point that we need to understand. Though we are advanced technology and very knowledge society, etc., but our understanding of ourselves is very, very limited. I think this is a possibility for all of you from different domains to come together to seek, understand, and create this infrastructure to develop it across universities. So I must also say that this effort is very important, especially people like all of you are present here. How India should be leading this activity in this country, where you are able to bring researchers to create infrastructure across various institutions where you do focused research. And that is the work that is done by this team who are behind this organizing. They have collected a lot of institutions across the country to come together, work on some common themes, also looking at how laboratories can be created, institutions can be created to do specific tasks at specific places. I think this is important, not to duplicate everywhere. Then share the knowledge across it and advance it. Because it is important for us, because understanding life is important for all of us, because life can also be threatened one day. I think it can be threatened in many, many ways, because the climate change is one part which is very easy to tell, life can be threatened. But then biological threats are also very much there present. The evolution is another interesting feature of life, Life never is static. Life is something which is evolving continuously, and it will continue to evolve with the changing environment. And how it actually evolves and will lead to what type of evolution, whether it is an evolution which will get abruptly stopped or which will ever thrive to become a better life at a later point in time, is something that we need to be worried about. Similarly, all of us human beings has an ability to think that we will ever remain on this universe and never extinct. Even if the universe is extinct, we will continue to thrive. I think this is a way human beings think, possibly, that we know that our life is very limited, especially the life on Earth is very, very limited, though the time periods looks very far away, but far away times are always possible to come, because it is not infinite, definitely not infinite. So we know that it will extinct one day. So what is the method by which we can live forever? That means humanity can live forever. Our gene chemistry can live forever. I think these are the questions we need to address to ourselves. I think these are fascinating topics and stories each one of you should discuss, think, and collaborate and work. Thank you so much for this opportunity to come and talk something like this. Possibly the discussions which is going to follow will give you more exciting contents for you to discuss and understand, and possibly collaborate and work in this domain, especially for students. Wish you all the very best in this conference. Thank you so much.
Thank you, Dr. Somnath, for your inspiring insights. We also extend our heartfelt gratitude to Dr. Shiv Kumar Kalyanaraman, CEO ANRF, for taking time out of his busy schedule and joining us today. Thank you, sir. We now invite Professor Tarun Soradeep, Director, Raman Research Institute, to the podium for his address.
Good morning. Shri Kiran Kumar, Dr. Somnath, Dr. Kalyanrama, and Professor Acharya and Professor Reggie Philip, and the delegates and organizers of the conference, many of the students here. Very warm good morning to all of you. Let me first start by, thanking GITAM University for inviting me, giving me the pleasure of addressing you, and particularly also the organizers of the conference. And so let me keep my address to a very specific, message that I feel is, I feel very compelled by. So if you ask me what compels me is the message that anything that humanity has achieved is actually, in my opinion, driven by grand scientific quests. Now, grand scientific quest need not be something that is defined by some Newton or something. It's just some pressing curiosity that humankind always had. So I'm sure everyone looks up at the stars, starting from whenever humanity came, and asked, where are we? What's our place in the universe, right? And that was opened up by Galileo, making a telescope. But to make his telescope, one should always realize that there was a lens maker who could make telescopes of that quality, right? So science and technology have always walked hand in hand to enable humans to answer pressing questions, which I call grand quests, okay? And I think you would, I was thinking of other examples, but today itself in the addresses you would notice Organics' space was very deftly renamed Life in Space, right? Because that's the question. That's the question human beings want to answer. Organics' space is a step towards it. For us scientists, we break up challenge into steps because that's how a formal method works. I mean, that's why, we have a profession. It's not, everyone is not able to, get into science because now science is so advanced that you have to take steps. You know that there are steps to be taken. So to me, I completely agree that, Organics in Space as a lovely consortium that has been set up may be well advised to, kind of pitch it more in terms of a very basic question that any thinking person, young student would have, and that is origin of life. That itself, I mean, Dr. Somnath said there are two views on it, and it's very possible given that life, at least complex molecules are being discovered almost on a daily basis on very distant places. It may be that the universe is, has the ability to carry life from one to the other and seed it, just like trees, sort of go out, disperse their seeds, and they, get planted on habitable planets and take life. Maybe that's what happens. But to answer that question, we need to be able to identify complex molecules. We can't go everywhere. Of course, ISRO being here, we'll probably, by the next 50 years, maybe we will be traveling across the solar system, maybe bringing samples from there. But beyond that, I'm in cosmology, so distances are far. But we do have instrumentation that allows us to look for complex lines, lines that are originating from complex molecules. That requires instrumentation, that requires sensitivity to pick them up, that requires an ability to interpret, right? So there have to be people who can do similar analog models in the labs and tell you that in these environments such things happen. And then you'll also probably, have people who can predict how these molecular lines would be, right? And many of you in this audience would be doing that on a daily basis. Many are experts here, and I just wanted to just point to the students how many different areas are involved. Like, of course, one thinks of, there's a whole quantum buzz. Now you might think, okay, is that connected to origin of life question? To me, it is obvious, because what are they going to do? They'll, what will quantum computers largely be able to do most successfully is to model materials, tell you, oh, this kind of a molecule may give you this property. And that can be done fast because your quantum computers can do that, whereas the classical methods take huge amount of time. Now, I think it's just a matter of few decades that complex molecules will be complex enough that organic chemistry people would start taking interest, and then biologists will start taking interest as these molecules being precursors to life originating life, right? Then you will ask, what lines should I look at? At this point, when we are saying we are looking for habitable worlds, we are, in a very limited sense looking for it. We have Earth, we see what signature would Earth give to a very distant civilization, but that's not the only thing. There may be other ways of looking for precursors. We know that we are seeing complex molecules in cold molecular clouds. We also know that, things can develop there. So to me, this whole thing where a consortium is developing in India, and it's a bottom-up approach, which I like, and scientists are coming together, and I would like to suggest that keep the questions very focused, at least when you're going to the funding agencies, and keep them grand, because everyone knows that we do day-to-day kind of things which are difficult to immediately excite people, right? If you're going in the lab and you say, you're going to do these many collisions and measure this, of course, the student may wonder, but the point is, what's the eventual goal? Not today, but in decades together, right? And also, I remember meeting Dr. Umesh, and he was saying, and he also mentioned that there's a 90 crore project that the consortium has come up with, and this is exactly the way to go. This disciplined way in which the community decides what are the pressing questions, and agrees on a few that they put together for funding. And I personally am very excited because this has been a journey that we undertook for gravitational waves. We started with something called the Indigo Consortium, because this required multidisciplinary things, so we brought engineers, scientists, everyone on that. It was a completely informal, completely unconnected to any institution. And that's important, because to keep a consortium from being, to be successful, at least from the things I learned were few, very, very good self-discipline. We, in hindsight, we were very, very self-disciplined. You have to tame egos, learn to work in a team. I mean, our academia, in my opinion, loves the competitive model more than a cooperative model. That needs to be overcome if you want to compete with the world and do these things at the top level. So finally, I should say that from the Indigo experience, the LIGO India project, in my knowledge, is the only project which was proposed to the government from a undefined consortium. We had no legal standing, we were not a society, we were not anything. Yet that project went through. It went through, you're talking about 90 crores here. We had asked for 1,200 when we started. 2 years back, 2,600 crores has been allocated. So this is certainly, I would say, a heartening way to see that consortia which are built bottom up and run well definitely can be a model for taking up very successful enterprises. And I wish you all the very best, and also I hope many of the students sitting here, because a consortium also means this was not going to be the next 5 years, it's next 25 years. And many of the students here would be inspired to join such a consortium and work for it. Thank you very much.
Thank you, Professor Tarun. To formally conclude this inaugural session, we now invite Dr. Abhishek Shahi, convener of Organics in Space 2.0, for the vote of thanks. Thank you to each and everyone who helped make this event possible.
Good morning, all. So I'm here to conclude this part of the session. On behalf of our organizing committee, I would like to thank all dignitaries for their presence here. I thank Dr. Sri Kumar Kalyanaraman, Sri A.S. Kiran Kumar sir, Dr. S. Somnath sir, Professor Tarun, Professor KNS, and Professor Rezi for their presence. We are truly honored, sir, to have you here. I would also like to thank all financial supports for this conference, which includes ANRF, Astronomical Society of India, GITAM University, and IIST. There is also private organizations who sponsored this conference, which includes Cisco, Pfizer, Global Bioscience, INCORP, ACS, RSC, Spectrophysics, Admont Optics, IRTech, Gomti Research, Sri Lakshmi, and Vasa Scientific. I would like to thank all other logistic teams, colleagues, students who are helping behind the stage for making this event successful. I would also like to thank all the participants, colleagues, and guests here. Last but not the least, I would like to thank GITAM University for all the supports whenever I need is provided. Thank you all, and we shall.
With that, we conclude the inaugural ceremony. We thank our dignitaries, guests, and all participants for their gracious presence. Let us now proceed with the scientific sessions of OIS 2.0. Here is the 2 days of learning, collaboration, and cosmic quest. Thank you, and Jai Hind. I request all the dignitaries to occupy the space off stage for the photo session followed by the tea break.
May I request everybody to stand so that it is better for the entire coverage, please?
The participants' tea is at the Graces Hall, and rest of the people can go outside for tea and coffee. Thank you.